Alberta tar sands and connect with existing pipeline infrastructure. We want to do this from the point of view of 3 different users. The first is a conservation NGO that has a couple of questions. They want to know if there are critical habitats near the pipeline, how many miles of the pipeline will run above the Ogallala Aquifer, and the likelihood that a natural disaster like an earthquake might damage the pipeline. So we'll start with their first question about critical habitat. We've brought that data in from ArcGIS Online, and to answer this question, we'll take advantage of the new ability to perform analysis on the layers in our map. In this case, we want to summarize nearby the pipeline, looking for critical habitat within 25 miles. Now, not only do we want to know the total square miles of critical habitat near the pipeline, we also want to know the different types of critical habitat that might be impacted. So we'll run that analysis. It's going to take about 30 seconds. So to save some time, we'll take a look at an output of that tool. And we can see that in the northern section of pipeline, we have about 612 square miles of critical habitat that might be impacted. And in the southern section, we have another 8.8. In addition to those totals, we also get information about each different type of critical habitat. That output is created as a standalone table that's supported in ArcGIS Online, and we can take a look at that here. So one of the critical habitats that stands out is where we have nearly 500 square miles of Topeka shiner habitat near the pipeline, and that is right about there. So we can take a closer look at that area. Another reason that we might want to take a closer look at this area is because this is where the pipeline is proposed to run above the Ogallala Aquifer. We want to know how many miles of pipeline will run above the aquifer, and to do that, we'll perform another analysis. This time, we want to summarize within the aquifer, looking for the length of the proposed pipeline. We'll run that analysis. Now, while it's running, we also wanted to take a look at the likelihood that a natural disaster might damage the earthquake. Something might damage the pipeline, maybe an earthquake. So to do that, to look at that kind of real-time data, we can bring in a GeoRSS feed. In this case, it's a GeoRSS feed that is hosted by the USGS, and adding it to the map is as simple as copying and pasting the URL and choosing to add the layer to the map. So we'll take a look at those GeoRSS feeds when they come in. Looks like we may have been asking too much of the browser, downloading a lot of earthquakes from that GeoRSS feed. Okay, we'll try that again. It's Murphy's Law. Here we go. Reload. It had to happen to someone. That someone is me. So, sorry. So we'll add that layer again, GeoRSS feed, I'm brave. And we can take a look at the real-time data right here in the map, very simply. I also know that that output is going to tell us that we had about 231 miles of pipeline running above the aquifer. So we're able to answer these very common spatial questions really simply using these simple tools in ArcGIS Online. The next user is an environmental justice organization that wants to make sure that the pipeline isn't running disproportionately through lower income or disadvantaged communities. To do that, we have to take a look at some demographics. And we've brought in some demographics from ArcGIS Online, but in this case, we're looking at unemployment. And to answer our question, we really need to take a look at income. So all we have to do is change the symbology on this dynamic map service to take a look at median household income instead of unemployment. And we'll take a look at median household income. And we can do some visual analysis. We can see the darker areas where we have higher income, the lighter areas where we have lower income. Now, we can do the visual analysis, but we want to dig a little bit deeper. We want to take a look at the underlying data. So we can open up that table, take a look at the raw data, and we can do things like filter. In this case, we want to see just the census tracts where the median household income is less than $30,000 a year. We can apply the filter, and we can see where those locations are in relation to the proposed pipeline. Now, at this point, we've done a visual analysis, we've done some tabular analysis. The last thing we want to do is a statistical spatial analysis. We want to analyze the patterns of median household income and find statistically significant hot and cold spots of median household income in this area. While that's running, we can take a look at the output. The areas in red are statistically significant clusters of high median household income. The areas in blue are clusters of lower income. And if we zoom into the Houston and Port Arthur area where the pipeline will terminate, we can see some interesting patterns that we might want to investigate further. And not only can we create maps and do analysis in ArcGIS Online, it's also a powerful platform for sharing and collaborating. In this case, we've created a group to share our data and our analysis from our Keystone Pipeline assessment. But this is a pretty sensitive topic, and for that reason, we created this group as a read-only group, meaning that only the group administrator is able to contribute content, so we ensure that we're providing authoritative data and analysis to the members of our group. In addition to being able to share maps and apps and data and tools, we can also share non-spatial content, like this PDF, which is hosted in ArcGIS Online, which really is a geospatial content management system, allowing us to share our work with a much broader audience. The last user is a journalist from Lincoln, Nebraska, who wants to visit the 5 pump stations that run along the proposed pipeline in Nebraska to interview communities and see how they feel about the project. The first thing we might want to do is plan the trip, and we can do that using the new ability to get directions right inside of ArcGIS Online. I can click on each one of these map notes here, which I just dropped down on the map. It's doing that reverse geocoding on the fly. And then we have some more advanced options. We have the option to optimize the order of those stops, and we can return to start. We can run that analysis, and we get our turn-by-turn directions. We also have the ability to add the route as a layer in our map. Once that route is a layer in our map, it opens up a lot of other possibilities, like performing additional analysis. In this case, we want to enrich that route with contextual information about the communities that we'll be visiting. We want to get some key demographic facts and also some landscape data within 5 miles of the route. And we can take a look at the kind of information that we get when we do that kind of enrichment. So we get information about land use and land cover, information about population, income, and other demographics. The last thing that we want to do is share the map. And a great way to do that is as a web application. Creating a web application is really easy to do using ArcGIS Online because of the apps that come as part of the platform. One of my favorites is the new Story Map template, which allows you to build a beautiful application using this very simple builder. And I've already done that, and we can take a look at that. So I built this app using the builder without writing a single line of code. And it was actually a lot of fun. You drag and drop the photos, you write the text, you set the look and the feel of the application, and you're able to share your work with everybody. So clearly, ArcGIS Online is so much more than a mapping application. It lets us solve problems, it helps us make more informed decisions, and it helps us share our work with the whole world. Thank you.
That's great. Thank you, Lauren.